On standing at the angle, label out the two sides that you got there just like we did yesterday. All right, what's 21 represent? The opposite adjacent hypotenuse. All right, and then go then go label out the 24. What's the 24 represents? It's the hypotenuse. Nothing's changing so far. Okay, based off what we talked about again yesterday, pick your trig function, sine, cosine, or tangent. It's cosine. So same deal, write up the exact same equation we did yesterday. The only difference is now it's going to be the cosine of the variable, cosine of the angle. So we're going to write cosine of, now you can write cosine of the question mark, or we can write cosine of x. The variables they're using as a question mark here, who cares? We'll just write cosine x then. And then it's the adjacent over hypotenuse. So in this case, we have both of those. So the variable ends up in one of three locations. Yesterday we saw two of the three locations, is either as the adjacent, hypotenuse, or opposite. Today we're going to look at when that variable is the angle measure, how we solve out for that. Okay. So now we need to get into calculator ready form. So we need to figure out how do we get x by itself here. All right, so before we do that, let's think about things that we've done before. All right, pause, don't need to write this down. But you've learned about inverses for years. The inverse of addition is subtraction. Inverse of multiplication is division. And then at some point over the last year or so, but I know this year, the inverse of square roots. What's the inverse of a square root? Taking the inverse of squares is the square root. Yep. I misspoke there. Is taking the square root of both sides. Okay. Everything has an inverse. Cosine has an inverse as well. So the inverse of cosine is this right here. To get the cosine kind of out of there, we need to ask our calculator what is the inverse of cosine, and that is this symbol right here. The inverse of cosine is cosine to the negative 1. So we say inverse of cosine 21 over 24. What is the specific angle that has a cosine ratio of 21 over 24? And in your calculator, there's a huge library that has specific ratios. And those specific ratios, it's going to go through that library and find that ratio for the cosine ratio that is 21 to 24. Now, back in ancient times, it's not me, it's even before then. Okay, don't laugh at that, Alex. All right. I see a smile on that face. All right. But before calculators, and we're talking before like 1950s, all right, before all that, there was huge trig tables. And in these trig tables would be specific ratios, sine, cosine, tangent, and then all these ratios that would say, hey, go find the ratio of 21 to 24, and then they would do an approximation of 3 decimals people have calculated, and then you would work with it. So we want to ask our calculator, hey, calculator, what angle has that specific cosine ratio? So how do we do that? All right, let's do that. Look on your calculator. Where do you see that cosine to the negative 1 at? It's right above the cosine button, right? And to activate that cosine to negative 1, as we've done randomly throughout the school year, as Sam suggested, you need now to hit the second button. Got your calculator. Calculator.
I have one. It just doesn't
Yep.
batteries.
Get batteries. Second cosine. Okay. Second cosine, and then type in the ratio. 21 over 24. And as we said, make sure you get the same answer here. If for some reason you're not getting the same answer, for some reason your mode changed from yesterday. It shouldn't. But what's the direction say there? Typically, angles get rounded to the nearest degree. So in this case, what are we going to round that to? 29 degrees. Okay. Angles typically get rounded to the nearest degree. So here we're going to round this to 29 degrees. Yesterday we rounded side lengths usually to nearest 10, and angles usually go to nearest degree. And that's it for today, basically. That's as crazy as it's going to get. Angles, second cosine. They also called arc cosine, arc sine, arc tangent. It's another way to say inverse of cosine. All right, but that's it. That we're like done. That's Let's go to the next one though. Let's take number 2. We did all the heavy lifting yesterday to know what sine, cosine, and tangent was. Today it's just using this inverse. Okay, number 2, go stand at the angle. All right, go stand at the angle. Oh, sorry, let's get our notes up. We're picking up where we left off yesterday with the notes, okay? Stand at the angle, label out the 12 and the 16. What's the 12 represent? Opposite, adjacent, hypotenuse. And the 16 is my, based off of opposite and hypotenuse, what do we got? Sine, cosine, or tangent? All right, create the equation. Sine of the angle you're standing at. Now, again, they're using question mark. Question mark is fine. You can just rewrite it as x. I don't care. All right, now if it actually was x or y, use x or y. But sine question mark is a little odd, but it's fine. And then 12 over 16. That's it. That's all I need from you. And then how do we get the question mark, or we get the variable by itself? Again, when the angle is what's being found, we're going to do the inverse. 12 over 16. You don't need to reduce it down or anything like that. I always have 1 or 2 kids thinking we need to reduce those sides down. Don't. Your calculator is going to reduce it down and find that specific ratio in its library. So second sine, or again, another way to say that is arc sine of second sine, and 12/16. Punch it in, enter. Again, angles, we typically round always to the nearest degree, unless it states otherwise. But that's what we're doing right now. So what do we got? 49 degrees. 48.5 rounds it up to 49 degrees. Okay. Again, that's as crazy as we're getting. All right, let's do a couple more here. Let's look at number 3. Number 3, stand at that angle. Go write them out. 22 and 33. Label them out. What's the 22 represent? And what's the 33 represent? All right, opposite adjacent. Opposite adjacent means sine, cosine, tangent. Tangent. And I'm looking for this equation exactly right here. Tangent of question mark is 22 over 33. Okay, that's it. Give me the question mark by itself. Get your calculator, Silas. Focus, bud. Okay, second tangent, or again called arc tangent. And go to your calculator, second tangent. Make sure again on your calculators you're hitting that second button, because if you don't, it's just going to give you tangent of 22 over 33. And just make sure again you're hitting everything correctly. And somebody get 37 there? Or sorry, not 37, 34. Okay, 34 degrees. All right, let's start jumping around because that's as really kind of as it goes. Let's go to number 6. Okay, let's go to number 6 there. Let's drop it down to 6. Okay, which variable want to go for first? X or Y? Sure, go Y. I don't care. Pick one and find it. Okay. Sam said he's finding X first. I'm gonna go find Y first. It doesn't matter. All right. Sam, go find X. Everybody else goes find Y. I don't care. As we've said before, on these things, it doesn't matter. Just watch where you're standing at the angle, because it's all relative to where you're standing. If Sam is going to find X first and we're all going to go find Y, to Sam's perspective, X is going to represent the opposite. If we're all standing on the other side and go and find Y first, at our perspective, Y is going to represent the adjacent, correct? So I'm standing at Y, everybody else is. Sorry, Sam. All right, I'm going to go find Y first. I didn't leave an equation for that, but who cares? I'm using adjacent hypotenuse. For mine, then, I'm using cosine. Sam, I believe, would be using sine, right? Now, as you're doing yours, I'm doing mine. Everybody else is doing, I think, cosine, or maybe not. You said screw it. You're going to go be a Sam. I don't know why you'd be with Sam, but okay. All right. Sam, when you get ready to find yours and we get ready to find ours, second cosine of 12 over 25, we should have a relationship here. I get 61, and Sam, you should have a relationship here. What did you get? Cool. You should get that. Okay. You found 29, you said, right? And I just found 61, right? There should be a relationship there, right? They should add up to 180 degrees because it's in a triangle. Sam found 29 and I found 61. Together, those two angles should add up to 90 degrees. I keep saying sine and cosine. What's cosine? That cosine. What do you think that co part represents when those two add up to 90 degrees? Think back to the vocabulary we've looked at before.
Oh my gosh.
What, Brianna?
It's getting there. I'm trying.
Keep trying.
There's supplementary and then there's, dude, complementary.
Correct. It's the complement of sine.
Jeez.
That's what we call it. The cosine is the complement of sine. So together, as Sam found 29, we found 61. Correct. Those are the sine and cosine is the complement to sine. So cosine, sine. There we go. So it doesn't matter again where you find out. Do we need to do sine? Sorry, do we need to do the other trig function to find the other one? No. Once Sam found 29, we found 61. That's fine, but just subtract it out from 180, subtract it out from 90, because again, it is the complement of the other one, right? All right, let's do some more down here. Let's take a look at number 7 then. Sketch it out if you haven't done so yet. Okay. We've done this before. Yes, Chris.
So when we have a problem like that, will we have to find x and y? Like take the put.
Yeah, it will be labeled better than what I had there, but yes, I'll have blanks for you. And you really don't need to do trig on one. Pick one, I don't care. Find me the other one by doing subtraction. Do trig on both, I don't care. You should still find both out. All right, number 7, sketch out that picture. All right, it's a right triangle. The only one that matters is the hypotenuse. Does it matter really where the leg goes? Doesn't say anything specific about that leg. All it says is the leg has to be what? 1.5. All right. But the one that does matter is the hypotenuse. Okay. Again, you guys sometimes have some play with things. All right. So sketch me out that picture, and all this one is saying here is, and it's kind of going back to Grace, what you asked just a second ago. Find me those two angles here, and I don't have the two blanks on that. All right, but we are asking for those two things here, the two acute angles to the nearest degree. Hypotenuse of 4, that's got to be locked in. But the right triangle, it has a leg of 1.5. Don't really care where you put that 1.5. It's not saying anything specific there. Where you want to put it, Harmony? Vertical leg or the horizontal leg? Horizontal leg, good choice. Or not, I don't know. Doesn't matter. And then the two angles, the two acute angles, x and y, I don't care where you call them. It's nothing specific of what you want to call them. All right. All it's saying in general is what's the measure of those two angles. Okay. Again, go right at it. What we just did a second ago with that previous problem. Okay. So stand at that x, stand at that y, whatever you want to do there, and go label out that 1.5. We know the hypotenuse is. And depending on which variable you're finding first, depends on what do you have, either the adjacent or the opposite. Okay? It's totally your call. Eric, what variable are you going to go find first, x or y? X. So Eric said let's go find x first. I'm going to go do what Eric's saying then. If I'm standing at x, so 1.5 then from Eric's perspective represents the opposite. If you're finding y first, because I drug my feet, then you're standing at y, you're finding what? The adjacent, I believe. Okay, so I'm going to use sine. Sine of x is what? 1.5 over 4. And because we're finding an angle, we are using the inverse, also called arc sine. And second sine. This is again what we call calculator ready form. Make sure you don't get lazy on us, and please write it out as that in calculator ready form. That is what SAT will do to you on the non-calculator part of the SATs. They'll write it out as sine inverse like that. Second sine to the -1. That's what you'll see it as on the non-calculator part of the SAT. And then when we go to that calculator, somebody check me on that. 1.5 divided by 4. Somebody got 22 degrees as one angle.
Yeah.
And then once you got one angle, you've got the other one very quickly. 90 minus 22 because it's the complement. 68. Don't need to use trig for the other one. If you want to, that's fine. But again, Grace, like you were asking just a second ago, got to use trig for one, and the other one, 90 minus the 22 we just found. Okay. All right, let's go with the next one, number 8. Sketch it out. Let's go back to our corner grid stuff. Okay. Go back to our corner grid. Kind of back to the beginning of the year. Yeah, Grace.
So, me and Daniel, he did cosine and I did sine.
Uh-huh.
And he got excess 68 and
Uh-huh.
I got excess 22. Does that matter?
Nope. But you go find the other angle.
Okay.
And you both got the same answers,
Yeah.
right? That's cool. You just got it in a different order.
So it doesn't matter which variable. Okay.
Does not matter. Just you got it in a different order. Yep. All I want is those two angles. Does not matter the order that you get them. You got the two angles. Yep. All right. Go with number 8 there. Again, label out that picture that's happening on that coordinate grid. So you've got those 3 vertices up there, A, B, C. A is at 1, 1. B is at 1, 3. C is at 4, 1. Sketch it out. All right. Don't wait on me. You guys know how to do that. We've been doing stuff on the coordinate grid all throughout the year. A is at 1, 1. B is at what? 1, 3. And C is at 4, 1. 1, 2, 3, 4. And when we sketch that out, well, hopefully you realize everything we're doing has to be a right triangle. Well, what do we have? We have ourselves a right triangle. And then what are we actually trying to find? The measure of angle C. So to find the measure of angle C right there. Now when we did this last week, we were running into all of 45s. That's the only thing I could do with you is a 45, 45, 90 triangle. We ran into like 3, 3, 3 or 2, 5, 5, 5 or 2. But we don't have equal legs here, do we? What's my 2 legs? What's the length of my 2 legs here? I get a length of 2 and, is it 3? Okay. And that's definitely not a 45, is it? Okay. But now we have trig. Now we can do a lot of other opportunities here to find every other type of angle out there for us now. So finding angle C using trig. All right, standing at angle C, that 2 and that 3 that we just have, what do we have then? 2 represents the, I'm sorry, and 3 is the meaning opposite adjacent, sine, cosine, tangent. There you go. And just like you guys are saying right there, I mean, it should be a pretty darn quick one. One day through, I'm not saying you're masters of it, but man, if you actually did the homework pretty well last night, it should be pretty quick on those. Day 2, even better. Tangent of C is 2/3. And after that, inverse. Second tangent, arc tangent is what we call it as well. Usually second tangent or inverse tangent is kind of our go-to. Show me that calculator ready line. Again, that gets you a little bit prepared for that standardized test, that SAT as well. And go to that calculator and second tangent. Again, get comfortable with using that calculator. Just don't sit back there and think all is good. Get comfortable with that calculator. Next year, as you move into Algebra 2, I don't care if you're going to 2 or 2 honors, over the course this summer, keep an eye on back to school deals. Usually right about 4th of July, they start coming out. Get yourself a graphing calculator. Algebra 2, 2 honors, you have to have a graphing calculator. And 37, I think it is. 37 degrees. Is it 37? Or no, wait. Sorry, I was looking at 6, right? So it is 34. Thank you. 34 degrees. Okay. Take number 9. We saw number 9 before. And the only thing, again, I can now do with you on number 9 is the exact same question, except now it's not a 45. The other day, again, we've had 45s on those. I can only give you a slope that was a slope of 1. But now I can give you a slope that's literally anything. Graph that line. Y-intercept of -4. But now that we have trig here, again, our possibilities are kind of endless of what I can give you. The slope of opens up of 2/3. Up 2, 1, 2, right 3. Up 2, right 3. I like to always give a few more points. Take your ID and make the line. Now, as we said before, we want to make this horizontal line. With it, you got a whole bunch of possibilities. It doesn't matter where you want to pick that horizontal line to make with it. Horizontal line, y equals something. Y equals, -4 down here, -5, -6. I don't care. I'm just going to go with that y-intercept really quick. We want to calculate the acute angle. There's my acute angle that we talked about with those 45s. And this is not a new problem. Only difference is we can now use trig with it. It's not going to be 45s. I know it's not a 45 because the slope ain't 1. And then make that right triangle. Pick a nice line though to drop down vertically to make a right triangle. It's not going to be as many opportunities because it's not a 45. It's not a 1-to-1 slope. So I'm going to pick some of these nice points that I just made for my slope there to make that line, and I'm going to drop it right here. That's just myself. I'm going to drop it from that nice point. And what did I get for my legs? 1, 2, 3, 4, and a run of 1, 2, 3, 4, 5, 6. Plus you. 6, plus you again, and a run of 6. Now, what you're going to find today, maybe, and more next week when we get some applications of trig, tangent is like the name of the game with applications. Tangent comes up quite a bit with applications of trig. And that's what we've got going again, isn't it? Tangent, we're going to call that x. Tangent of x is 4, 6. Tangent, again, is our most popular one with applications of trigonometry. It just does. Now, we just did that last one, though. We just did 2/3. 2/3 and 4, 6. Isn't that a similar triangle? All right. That's that library I was talking to you about in your calculators. So multiplied by, what is that, 2? Multiplied by factor 2. That's what your calculator is reducing and looking at those libraries when it says, hey, goes into the library. It's looking at really what tangent ratio is 2/3. And that's looking at an angle of what? 34 degrees. Okay? All right, let's keep rolling along here. We saw that yesterday. If you know one ratio, you know the other two. Draw me out that picture. Okay? You've got a tangent ratio that is 1. Find me the other two ratios. Okay? So let's take number 10, as we did yesterday. Sketch me out a right triangle. These are all revolving around right triangles. So that's this school year. Next year in Algebra 2 and pre-calculus, still get outside of right triangles. But we're all about right triangles to make our lives easier. So sketch out a right triangle. I don't care what your right triangle looks like. I don't care how it's orientated. Sketch out a right triangle. Myself, this is my go-to right triangle, but sketch out a right triangle. Okay? It might look isosceles, it might not. Who cares? Just sketch out a right triangle for a nice visual. And then put an angle up there. Put it at the top angle, put them at the bottom angle. I don't care where you put your angle. Again, it does not matter. It's all relative. All right. Now, throughout the tangent ratio, put yourself in reverse like we did yesterday as well. Wherever you put the angle at influences your tangent ratio here. What's tangent represent? TOA. That's my what? OA. That's my opposite and adjacent. So what's my opposite and adjacent in my triangle? Opposite and adjacent, right? All right. Now, throw that 1 in there. So with that 1, like we did yesterday, I think yesterday was what, 3/5 sine ratio? I think it was the 3/5 ratio I think we did. Okay, tangent ratio is 1. So what's that going to be for my opposite and adjacent? What's my opposite and adjacent when it says 1? Silence is concerning. So what's my opposite and adjacent?
1.
And? somebody sees something. I gotta have two numbers first though, besides the square root of 2.
Oh, 1.
Thank you. 1 and 1. Okay, it's got to be a fraction. I have two sides up there. I got an opposite and adjacent, and 1 is just 1 over 1, right? 1 is just 1 over 1. Okay, I have an opposite and adjacent there, and 1 over 1 is just simplifies down to 1. Now, Lucy then just told me a square root of 2, because when I put that 1 and 1 in there, it takes me back to last week. My two legs are congruent, and as soon as I see two legs are congruent, it's a 45, you better know it's an isosceles right triangle. When you see congruent legs, you better know I have myself an isosceles right triangle. And as Lucy then pointed out, this is a 1, 1, square root of 2. This has nothing really to do with trig at all, besides knowing the tangent ratio was opposite to adjacent. All right, so now write me up the cosine ratio. Okay, cosine ratio is what? A over, okay, so what is my adjacent? And what is my hypotenuse? Okay, you give me that answer, great. But what have we been doing for the last month or so? Simplify, rationalize the denominator. So when we touch base with things over this next couple of weeks, you give me that as an answer, that's going to be fine, but I'm going to take off partial credit there because that's not simplified. From day one, we talked about simplifying radicals. That includes rationalizing the denominator of the last month. Rationalize that denominator. Again, we are at the point here where majority of you should be able to rationalize that in your head. You should be able to tell me root 2 over 2 like that. You go into physics next year in algebra 2, you're going to be doing what we call the polar coordinate system. Get to know those very quickly. It's going to be root 2 over 2. If you're not getting that root 2 over 2, all right, that's how we're getting it. Perfect square of 4, and the square root of 4 is 2. Go do me the sine ratio. Go do me the sine ratio. Sine ratio is opposite over hypotenuse. And in this case, what do we have? 1 over root 2, and well, what's going to be the same thing, right? And in a 45-45, hopefully you kind of realize legs are the same, isosceles right triangle, and it's going to turn out to be the same. So root 2 over 2. If you don't remember that, it's fine. Just follow the math. Okay, we're doing the trig ratios from yesterday and this morning. What I've heard from you has been good about knowing the trig ratios, opposite, adjacent hypotenuse. That's good. Okay, I'm hearing good stuff about root 2's and rationalizing the denominator. Just follow the math that we've been focusing on. All right, flip it. Let's see what the backside does for us. Come on. All right, let's take number 11 there. Okay. Same deal. Take the next one. Throw that sine ratio into a right triangle. Okay? Give you a minute, chew on that one. Based off what we just did, chew on that next one. 1/2, what do we got there? Go, 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 go. Then go. We just did the previous one. Go through that next one in there. Sketch up that picture. Again, I always like pictures. Pictures are helpful instead of keeping track of it in your head. Get them out this way. We're missing a side in that triangle once you get sketched out. How can you find that missing side then? Good old Pythagorean theorem is correct. Now, as you roll into Algebra 2 and you're tasting physics next year because you're a sophomore, you're going to see a lot of blending of trig and ideally, you actually see this. This is, don't need to use Pythagorean theorem. This is not a 45, but this is our other special right. This is my 30, 60, 90. You're going to see a lot of blending of special rights and trig. All right, why do I know this is my 30, 60, 90? I got a leg of 1 and a hypotenuse of 2. And in the 30, 60, 90, when that happens, I have a leg of 1 and a hypotenuse of 2. When you just did Pythagorean theorem, if you did Pythagorean theorem, anybody, what did you find for the missing leg? You found it to be out root 3. Okay? If you didn't see that, that's fine. But those are those patterns let's start trying to develop on. Okay? Take some time, all right? But try to keep those in mind. If you see a leg and a hypotenuse that's been doubled, that's always going to be the case. Okay. Now that we have that, we can finish this thing off now for the adjacent hypotenuse. Or sorry, cosine and tangent. All right, but if not, Pythagorean theorem it. All right, cosine is the adjacent hypotenuse. So what do we have? Root 3 over 2. Do I need to rationalize that? Nope, that's nice. And then tangent. What's my tangent going to be? Opposite over adjacent. So I heard 1 over root 3, correct? Opposite over adjacent. Now with opposite over adjacent, I need to rationalize, don't I? Go ahead and rationalize. Now we're going to do this one enough times over the next couple years with you, between me and your next year's teachers, that you should be able to kind of remember that it's going to turn out to be, or see it as root 3 over 3. Again, there's going to be certain things that you're just going to get slammed on. You'll memorize it. Okay? Not probably this year, maybe, for some of you, but you'll get it in algebra 2 and physics, that's for sure. Okay? Root 3 over 3. All right. That's what we'll just, again, I didn't get a chance to come backwards to some of the other ones, but we'll just catch it then over the next couple days. We still got time, but we got plenty of things through that we got through the major stuff, so that's fine by me. Okay? So we'll catch up with the random bits and pieces that we did not do, but it's not as hugely important, but we got through the major topics just now. All right? So we got about, we